Hello everyone, welcome back to the Olympiad Mathematics Bhutan Monthly Math Challenge. Today we'll be discussing the solution to the question handed out in July. So this is the 19th question that we have given out. This is the 19th month since we have started handing out questions monthly. So I hope you're all answering these questions and having fun. So the question for the July month problem was, consider the set of integers from 1 to n. For every non-empty subset, we can calculate an alternating sum by arranging its elements from largest to smallest and alternating between addition and subtraction. So let's try to understand the question first, right? What is an alternating sum? So let's say your value of n is something like, let's say 5, right? So that will give you a set of numbers containing elements 1, 2, 3, 4, 5. Am I right? Now the alternating sum of this set of numbers will be something like, let's see, the alternating sum is given by S. It will be something like, okay, so you take the biggest number and then you subtract it with the second biggest number. So you take all the elements of the set in descending order, right? You write the biggest number and then the second biggest and then the third biggest and so on. And then you keep on alternating between subtraction and addition. So 5 minus 4 plus 3 minus 2 plus 1. So 5 minus 4 is 1 plus 3, 4 minus 2, 2 plus 1, 3. So your alternating sum for this set will be 3. I hope you got that. Let's look at other types of sets, right? What about empty sets? What if you have an empty set? Well, your alternating sum will simply be 0 because there are no elements in this set. Okay, what if you have like a singleton set like this, a set containing only 3? Well, your alternating sum will just be 3 in that case. So that's what alternating sums are. I hope you got that. Now, okay, so the question is asking us, if the value of n is equals to 7, if the value of n is equals to 7, what is the total sum of the alternating sums of all possible non-empty subsets? Excuse me. So when the value of n is equals to 7, you get a set containing numbers 1, 2, 3, 4, 5, 6, 7, right? So this will be your set. Now the question is asking us, okay, you have a set of numbers, right? From 1 all the way up to 7, containing elements from 1 all the way up to 7. And there are many possible subsets for this. So a possible subset for this could be something like, it could be an empty set, right? An empty set is a subset of this. It could also be a singleton set. So you just pick any element you want. And this is also a subset of this. So I hope you all know what subsets are. You could just pick a few numbers from here. That will also result in a subset. So that's what subsets are basically. And the question is telling us, okay, there are a lot of subsets for this set, right? Well, I want you to find, well, the question wants you to find the alternating sum of all of those subsets and then add the alternating sum of all of those subsets and then find the sum. All right. So what comes to mind first? Well, what comes to mind first is we could possibly list down all of the possible subsets for this set. So there will be many subsets for this set. We list them all down. After listing them all down, we find their alternating sums. After finding their alternating sums, we add their alternating sums and then find the answer. But that would be us brute forcing our way to the answer, right? It wouldn't be a very sophisticated or an innovative way to find the answer. Plus, it would take you a lot of time. And if you made even a simple or small error in your method, then everything just falls apart. Your final answer will be wrong. So whenever you encounter questions like this, what you want to do is you want to find patterns, or you want to think of ideas which you can use to solve these types of questions in a more sophisticated or an innovative way. So okay, so let's try to solve it in a more interesting way. Am I right? Now let's first try to see how many possible subsets there are for this. So let's try to make subsets for this set, right? So when making a subset, what you can do is, okay, you can either include or you can remove one, right? You can either include the element 1 in your subset or you can leave it out. So you have two options, right? So 2. And then what do you have next? You have the element 2. You can either include it in your subset or you can leave it out. So 2 times 2. You have the element 3. You can either include it or you can leave it out from your subset. So you keep on doing this 1, 2, 3, 4, 5, 6, 7 for all of the 7 elements, right? So this is how you'll make the new subset. And then for each element, you have a decision to make. You can either leave them in or take them out of your new subset. So what are we left with? We have 2 raised to 7, which will give us 128. So there are 128 different subsets for this set. Now, if you were to brute force your way through this, you would have to create 128 different subsets and then find their alternating sums and then add up all of the alternating sums and then get to the answer, right? But that's not what we're going to do here. Just so you know, 128 also does include the empty set which contains no elements, but we can leave it here. We can leave it in. You might have noticed that the question says we want non-empty subsets, right? So why are we including this empty set here? Well, it's okay to leave it here. It's completely fine because the alternating sum of the empty subset will be 0, and adding 0 will not change your answer. So leaving the empty subset does us no harm. Also, it's good for symmetry, right? Now, what you will notice is for every possible subset that you have, you can divide them into different groups. So what you will notice is every subset will either have the largest number 7 in the subset, or it will not have the largest number 7 in the subset. So if I take any subset I want, any subset, let's say I take 1, 3, 4, 5, right? 1, 3, 4, 5. This is a subset, right? I created a unique subset for this set. What I can also do is I can create a partner for this subset by simply writing this subset again and then adding the biggest element 7 at the end. And I can do this with all of the subsets. We have the empty subset, right? Well, his partner will be another empty subset, but in the subset you toss in the largest element 7, which makes it a singleton set. So yeah, this is also a partner. These are pairs as well. So I hope you got that. All of the possible subsets can be made into two groups: subsets that contain the element 7 and subsets that do not contain the element 7. So yeah, I hope you got that part. Now let's calculate let's calculate alternating sum of the pairs and add their alternating sums. So we have made the subsets into pairs, right? So let's try to see how we can calculate their alternating sums. So let's say your first subset, the subsets that do not contain the number 7, their alternating sum can be given by the formula S is equals to A1. A1 will be your the biggest element in your subset, minus A2 plus A3, minus all the way up to, so you're alternating between subtraction and addition, all the way up to, let's say, AK is your smallest element in the subset, right? That makes sense, right? So this will be for your subset, which looks something like this, right? So yeah, I hope that makes sense. This is what your first subset will look like. Sorry, this is what your first subset will look like. Now, what will its partner subset look like? That's the question we have to ask. Its partner subset, let's say it's S dash. So its partner subset will look something like, the alternating sum of its partner subset will look something like, well, what's the biggest element we have? It's 7, right? And the partner subset always contains 7. So we will always begin with 7 minus A1 plus A2 minus A3 plus all the way up to ak. Am I right? Now, what you might have noticed is, uh, since 7 is larger than every other element in the set, it will always go at the very front. Am I right? So by adding 7 to the partner subset, uh, it's all and then looking at the formula for its alternating sum, the partner subset will flip all of the signs. So A1 had the positive sign in front of it, right? Now it has the negative sign. A2 had the negative sign in front of it. Now it has the positive sign. So all of their signs have been flipped, right? So what can you do? You can take -1 out from this entire group, right? So all of these numbers, you can take -1 out of them, and you're left with A1 minus A2 plus A3 minus all the way up to AK. Am I right? Yeah. Now, what does this look like? Does this resemble anything? Yes, this resembles, this looks exactly like the formula we made for the alternating sum of the first subset that we have, which does not contain the element 7. So S dash looks something like 7 minus the alternating sum of its partner subset. So 7 minus S. I hope that makes sense. Now, now that we have them in pairs, let's try and see what the sum of the pairs will look like, right? Let's just try to see that. So the first subset S plus its partner subset S dash, let's try to calculate their sum. So S is just S, right? But S dash can be written as 7 minus S. And the alternating sum of the alternating sum of the first subset actually cancels itself out, and you're left with 7. So yeah, this, we're getting somewhere, right? We have 128 subsets, right? And you have made them into pairs. So how many pairs are there? There are 128 divided by 2, which is what, 64 pairs. Am I right? So you have 64 pairs, and each pair has a sum of 7. So when you add the partner subsets, you get 7 every single time. So what does that mean? That means if you were to multiply the total number of pairs of partner subsets that you've made with the sum of the alternating sums of the partner subsets, which is 7, you will get 448. Am I right? And that's your answer. That's how you got to the answer. I hope you understood what we did here. What we did was, we first looked at the total number of subsets that can be made from this set, and then what we did next was we divided the total, all of the subsets, into two groups. A group of subsets which do not contain the number 7 or the largest element 7, and we also create a partner for them, a partner which looks exactly like the first subset, but the difference is it has 7 in it. So we grouped them into pairs, and then what we noticed was, when you add the alternating sum of both of the pairs, you get 7, right? We proved this here, and then after we got here, the answer was relatively simple, right? So 128 divided by 2, you get 64 pairs. Am I right? 64 pairs. So what do you want to do if you want to find the total sum of all the alternating sum of all of the subsets? Well, you do 64 times 7. 64 is the total number of pairs. 7 is the sum of the alternating sum of the pair, which gives you 448 as your total sum. So I hope that sums up what the question was talking about. That, I hope that sums up the solution. I hope you understood what I taught today. It's a very interesting method, am I right? Creating pairs and adding them and getting to the answer just like that. Much quicker and much more interesting than brute forcing your way and listing down all of the possible subsets and finding the alternating sums and adding their alternating sums to get to the answer. So very interesting question. I hope you understood what I taught today, and thank you for listening. I hope you join us next time.